Mr. Clown here from Clown Maths. Today we're going to be looking at some advanced higher maths, and we're going to start a topic on partial fractions, which will lead into our integration topic, which we can't get to until we actually know how to do partial fractions. So partial fractions, let's have a look at what it is first of all. You should already know from your previous work in maths that you can add fractions, whether they're algebraic or not. And if I were to add these two fractions, then the answer would be 2 times x plus 3 plus 1 times x minus 1 all over x minus 1 and x plus 3 as our common denominator. So essentially we've times these together to get a common denominator, and an easy way to think of this is I've done 2 times this one plus 1 times that one. And then we would simplify this. So if I simplify the top, that gives me 2x add 6 plus x, take away 1 all over our bottom, which will leave factorised x minus 1 and x plus 3. Because a factorised expression is simpler than an unfactorised expression. So then to simplify our top, we've got 3x and we've got plus 5 over x minus 1, x plus 3. If I wanted to express a fraction as partial fractions, it would be doing this backwards. So it would be starting from this expression here and finding out that this is our partial fractions. So let's just go through some definitions. A rational function is just a polynomial divided by any other polynomial. Remember, polynomial is just any expression with algebraic terms, x squared, x cubed, and so on. So if I've got some polynomial divided by some other polynomial, we call that a rational function. So then we can have proper and improper rational functions, just like we can have proper and improper fractions. So a proper rational function is when the degree of the top polynomial, p of x, is less than the degree of the bottom polynomial, q of x. So let's have a look at examples. If I had a function on the top as x plus 3, that's got a degree of 1 because the highest power is 1. X squared plus 3x minus 4 has got a degree of 2 because the highest power is 2. That would be a proper rational function because the one on the top is less than the one on the bottom. If I had 3x squared minus 11x plus 5 on the top, that's got a degree of 2. If I have x cubed minus 3x squared plus 2x on the bottom, that's got a degree of 3. That again would be a proper rational function because the one on the top is 2, the one on the bottom is bigger, which is 3. Okay. Improper rational function is simply the opposite, when the degree of the top function, p of x, is greater than or equal to the degree of the bottom one, q of x. So for example, x squared minus x plus 6 over x squared plus x minus 2 would be improper because the degree is the same, or x to the power of 4 plus 1 over x squared plus 2x would be improper because 4 is bigger than 2. When you've got an improper rational function, you can actually divide the polynomials together and get some sort of answer, some polynomial plus a fraction, just like you can divide numbers. So proper rational functions can be expressed as partial fractions straight off the bat. We can just go and do it. However, if you've got an improper rational function and you want to express it as a partial fraction, the first thing you have to do is do some algebraic long division, because you can express it as a polynomial plus a sum of proper rational functions, or a bunch of basically partial fractions. Okay, in today's video we're going to focus on just proper rational functions, and we're going to focus on a specific type. Going to call this type 1. It's the type when distinct linear factors in the denominator. Okay, so the denominator is the bottom part of a fraction. That what I mean by distinct is different, so it could be like x plus 2, x plus 3, x minus 4, or it can be reduced so that it looks like that. By reduced I mean you can factorize the bottom expression, and that means that you end up with a bunch of linear factors. Linear just meaning no powers bigger than 1 on the x, can't have x squared or x cubed or anything like that. If that is the case, and you've got a bunch of different linear factors in the denominator, the formula for partial fractions is this. It's a over some linear factor plus b over it plus c over it, and on to infinity depending on how many you've got. We'll deal with ones with just 2 or 3. So for instance, if I had x plus 7 over x minus 2x plus 1, I wanted to write that as a partial fraction, it would be a over the first factor plus b over the second factor. And then we'll just try to work out what a and b is. Similarly, if I had this one here, 2x over x squared plus 5x plus 6, well, x squared plus 5x plus 6 is not linear, but I can factorise it. I can reduce it to x plus 3 and x plus 2. And because of that, I then get a over x plus 3 and b over x plus 2. And the game today will be, how do we find these a's and b's and maybe c's? Example 1 says, express in partial fractions, x plus 7 over x minus 2, x plus 1. So since it's distinct linear factors, I can immediately write x plus 7 over x minus 2, x plus 1 equals a over the first factor plus b over the second one. Now I can go ahead and try and add these together. So common denominator for times them together is this. So that means that the top, the numerator, is going to be a times this plus b times that. So if I do that, that implies that a times x plus 1, thinking of it like a cross, plus b times x minus 2, must equal the numerator that's already there, which is x plus 7. So we can simplify that. Multiplying out our brackets, we get ax plus a plus bx minus 2b equals x plus 7. Now if we write our x parts together, on the left hand side we get ax plus bx. And if we write our other parts, the parts without any x's, in other words, we get plus a minus 2b equals x plus 7. Well, these x parts must go with this x. And this bit here, which will just be a number because there's no x's, must go with this number. Okay? So that means that, taking x out as a common factor, a plus b times x plus a plus minus 2b equals x plus 7. So a plus b must equal 1 because the coefficient of x here is 1, so a plus b must be 1. And similarly, I get a minus 2b must equal 7 because that's our numerical part, and that equals to 7. So we can now solve a couple of equations. Taking away these from each other, we get b minus 2b, so 3b equals 1 minus 7 is minus 6, so b is minus 2. That implies that a must be b. So x plus 7 over x minus 2, x plus 1 equals 3 over x minus 2 minus 2 over x plus 1, because a is 3 and b is minus 2. 2x over x minus 1, x plus 1. So again, it must be 2x over x minus 1, x plus 1 equals a over x minus 1 plus b over x plus 1. So that implies that ax plus 1 plus bx minus 1 must equal 2x. Now let's do a little trick with this one. Instead of solving any simultaneous equations, we can let x be any number, because x could be any number. So why don't we just say, let's let x equal 1, because that will eliminate this whole thing. 1 minus 1 is 0. That implies you get a times, I'll write it out long so you can see it, 1 plus 1, plus b times 1 minus 1 equals 2 times 1. A times 1 plus 1 is 2a. 1 minus 1 is 0, so 2a must equal 2, which means that a equals 1. Now you can do that trick anytime, just let x be any number, and if you can eliminate one of the letters, the a over b, it will immediately give you what you need. Now, since we know a equals 1, we can now go and work out b. So we're going to do the same trick. We're going to let x equal minus 1 this time. If I let x equal minus 1, going back to the original expansion, I get minus 1 plus 1 is 0, so that goes away. Minus 1 is minus 2. I get minus 2b equals 2 times minus 1, which is minus 2. So b equals 1. And we've done it. We've now go back to our original question. x over x minus 1 x plus 1 equals 1 over x minus 1 plus 1 over x plus 1, because a and b are 1. Example 3 expresses partial fractions 6x over 4x squared minus 1. Well, this is not linear at the moment, but if we can make it linear factors, we're fine, we can do it. So let's try it. 6x minus 1 over 4x squared minus 1, well that's 6x minus 1 over a difference of two squares, 2x minus 1, 2x plus 1, so that must equal a over 2x minus 1 plus b over 2x plus 1. So that means we can do the same as we've been doing. That implies that a times this, 2x plus 1, plus b times this, 2x minus 1, equals the top of our fraction, which is 6x minus 1. Let's try and eliminate one of those brackets again. So we need a number for x so that this bracket disappears. 2 times x plus 1. We want it to equal 0. So that means that x must be minus a half. So if x equals minus a half, we'll just say let x equal minus a half, then you get 2 times minus a half, which is minus 1, plus 1 is 0, so the a disappears. So we get b times 2 times minus a half is minus 1, so minus 1, take away 1, equals 6 times minus a half. Alright, I'll just write 6 times minus a half so you can see it, take away 1. So then we get minus 2b on this side equals minus 3 minus 1, minus 2b is minus 4, implies b must be 2. We could do the same trick to get a, or we could substitute b back in. Lots of things we could do. I'm just going to do the same trick. So let's say let x this time equal, so we're going to try and eliminate with b's, so 2x minus 1 equals 0, so x is going to be a half. You can always do this work if you have to at the side. So if x is a half, we get a, should be able to see that that's just 2a. 2 times a half is 1, plus 1 is 2. This disappears because you get 1 minus 1, which is 0. 6 times a half is 3. Take away 1, which is 2, which means that a must equal 1. And we're done. We've got our a and b. So final answer, that equals 1 over 2x minus 1 plus 2 over 2x plus 1. Last example of today, expressing partial fractions 6x squared minus 10x plus 2 over x cubed minus 3x squared plus 2x. Now, as you're going through this, if your top one can be factorised, you're going to have to check that it can be. Most of the time it won't be able to do, but just double check. We can't actually factorise the top. It's the bottom that's important because that's not linear. So keeping our top as it is. Our bottom one factorised, though x is a common factor, so you get x squared minus 3x plus 2, but I can factorise that further. Because you get x, double brackets, x and x, 2 and 1, minus 1 minus 2. So since we've now got linear factors only on the bottom, that's going to be a over x plus b over x minus 1 plus some number c over x minus 2. So, being very careful, this one's been times by this, so we've got a x minus 1 x minus 2. The b one's been times by x and x minus 2. And the c one's been times by x and x minus 1. That equals the whole of the top, 6x squared minus 10x plus 2. Quite handily though, we've got cx and bx, so we can just let x equal to 0 to eliminate both of these, and we'll get our a straight away. So let's try that. Let x equal 0. Then that means we get a times minus 1 times minus 2 plus b times nothing, which is nothing, plus c times nothing, which is nothing, equals 6 times nothing, which is nothing, 10 times nothing, which is nothing, so just 2. So 2a equals 2 implies a equals 1. We've now got a number for a. We can now try and find b, because we can let x now equal 1, because if we let x equal to 1, 1 minus 1 is 0, 1 minus 1 is 0, so it will eliminate the a and c. So if we let x equal to 1 here, then we will get b times 1 times 1 minus 2 equals 6 times x squared, so 6 minus 10 plus 2, the right hand side. And notice 1 minus 1, 0, so this is all gone, and 1 minus 1, 0, so this is all gone. So fixing that up, 1 minus 2 is minus 1, so minus b equals minus 4 plus 2, which is minus 2. All that implies b equals 2. The only thing left to get is our c, so let's go back up again. If we let x equal to 2 this time, we can eliminate this one and this one, and our c will drop out. So let x equal to 2. Then that means this will be gone and this will be gone. You'll have c times 2 minus 1. Equals the right hand side. 6 times 2 squared is 6 times 4. Minus 10 times 2. Plus an extra 2. So the left hand side, we've got 2 minus 1 is 1, so that's just 2c. And the right hand side, we've got 24 minus 20, which is 4, plus 2, which is 6. So c equals 3. So we started with this, so that means that, remember, a is 1, b is 2, c is 3. We get 1 over x plus 2 over x minus 1 plus 3 over x minus 2, and we're done. This has been Clear Maths. Today we've done some advanced higher maths. We've started to look at partial fractions. We've defined what they are. We've defined the names of rational functions and proper rational and irrational functions. And we have also looked at how to get partial fractions from a polynomial divided by another polynomial where the denominator is distinct linear factors. Stay around for this series on partial fractions, and then we'll lead into integration. Take care, stay safe, and goodbye.